Yeah, so what did we actually find? And details about this you can actually find in our Black Hat Europe paper. So first of all, a large number of apps that we actually ran through this approach was goodware apps, right? So here we are not just interested in malicious apps, but actual normal apps by good people who are trying to do a good job and try to store perfectly legitimate data in these services, but who are probably doing it in an insecure way by just using these static credentials, right? And so what we found here was, for instance, car accident reports, birthday information, which might be sensitive, in general, contact data by some apps, Facebook information such as friends and blocked friends. So this was not directly extracted out of the Facebook app, but out of apps that use the Facebook API. Then photos, phone numbers, in-app purchase information, actually verified email addresses. That would be very nice for spammers, location data, and so on. So a lot of relatively sensitive data, even photos, that you would definitely not want to just be able to extract that easily. But what we also found, and that was really interesting, was even parse-enabled malware. That's something we actually didn't foresee. So even malware programmers are using backends as a service, right? So for instance, they use cloud services to store intercepted SMS messages, to store stolen data, to actually implement command and control servers, and also to distribute command and control tasks. So that was actually also really interesting. We also looked into one particular app a little bit deeper. That was a really interesting app that we really dissected piece by piece. So if you want to learn out more about how these apps actually work and what their modus operandi is, I really invite you to also look at this paper that we published back then. That gives you some really nice case study on this whole landscape. And yeah, of course, this is also problematic because this data can be extracted as well, right? Maybe command and control commands is not so bad, so you can even take down malware actually that way. But if there's stolen data from various phones or devices stored in these backends, that's nothing that just anybody should be able to access all that easily. And yeah, like I already said, this was a sensitive subject, so we actually had some responsible disclosure process back then with Amazon Web Services, but also with parse. And about the parse one, I want to talk a little bit about here. So first of all, we had full access to about 100 tables and partial access to 32 more. So all in all, this was more than 56 million data points. And this was just in a few dozen apps or so, right? It's not like we really analyzed millions and millions of apps. So if we had analyzed many more, I'm sure we would have found many more. So in April, we contacted Facebook with a few samples. They verified it and asked for more data. We provided all the information. And then later, Facebook forwarded everything to parse. We assume that they contacted the developers. Unfortunately, I have to say, we didn't publish this, but we redid a similar study about a year and a half later, just to see how they actually responded to this, right? So ideally, I would have hoped that they actually would have changed the APIs so that as a programmer, you can't really use these simple static authentication mechanisms anymore. But back then this was not yet the case. And we also found that the number of apps, or the fraction of apps, let's say at least, that was using these simple authentication APIs had not gone down. So it was actually still the same problem. I'm reasonably sure if we were to do the same study again today, we would probably see similar problems still. So if any of you is interested in following up on this and running a similar study, I invite you to speak with me and we can probably collaborate on that. So yeah, like I said, in November actually, right? So we actually did a small study again, still had full access to 99 tables and partial access to 33. So yeah, not a lot is changing. With Amazon, we had similar results. So here we actually found also interesting data, slightly different data. So Amazon is used more generally as a cloud service. So there we also even found server backups. So that was interesting, right? So I mean, apps have nothing to do with server backups, right? So it turned out, nonetheless, that the same credentials that the app used to access some Amazon buckets could also be used to access these buckets in full generality, and then within the same buckets, you simply had server backup sitting there. There was some baby growth data by certain baby, monitoring apps. We found more photos, we found private messages, we found lottery data. I'm not sure we would have been able to actually forge the lottery numbers, but nonetheless, pretty disturbing. We found website backend data, right? So we would have been able to not just read, but also manipulate websites, injecting malware, doing all sorts of things, maybe even, forwarding, money transactions, whatever. Pretty disturbing. So this is definitely nothing you want to be able to access, right? And so again, this is data, or at least the website contents, it's data that no app should have access to, right? But just because it was sitting in the same cloud buckets that were accessible through these credentials, you still had this open to everybody. Yeah, and that really concludes everything that I wanted to say about this experiment. So again, just for you to take away, using Harvester, it's super simple to actually extract all of this supposedly obfuscated data out of applications. So the point you should take away from this is, first of all, no statically derivable data should be used for secret key storage, right? In an app. So whenever you have secrets that need to be stored in an app, derive them dynamically from user secrets, right? Or at least store them in some secure place on your phone, like a secure enclave or so on. And the other point to take away is that using a combination of static and dynamic analysis can be very powerful, right? So we were actually able to build a very powerful tool here that extracted very sensitive data, and that would not have worked just purely statically, right? I mean, for some apps, a purely static analysis would have been sufficient. Like I said, many apps don't even use obfuscation, or at least they didn't at the time. By now, I think that might have changed. But using this hybrid or blended approach in Harvester, even obfuscation didn't really work at all. And yeah, so that's all I want to say about Harvester. In the next part, in the next video, I will be talking then more about augmenting static analysis with heap data. I'll see you then.